Okay, we're going to talk a little bit further into investigating matter, and specifically when we talk about bonding here in lesson 12. So there's several different types of bonds. We're going to focus on two right now, ionic and covalent. So an ionic bond is a metal and a nonmetal. And so when you look at your periodic table, we are focusing pretty much just on the S block, that's this block here, and the P block on the other side. I'm not going to talk at all about the D block or the F block. One important thing that you should notice on your periodic table, and you might want to print one out and draw it out and memorize it, is that between the S block and the P block there's a pattern. So as you read from left to right, it goes +1, +2, +3, +4, and then back down. -3, -2, -1, 0. So it's a 1, 2, 3, 4, 3, 2, 1 pattern. Just remember that the ones on the left are positive and the ones on the right are negative. So why is this important? Because this is going to help you when you go to do bonding. So if you have that memorized, we can do some naming and we can also write out the names for things. Oh, let me back up here 1 minute. So on the left-hand side of your metalloids are going to be your metals. So like I said, your ionic compounds are your metals and your nonmetals. Your covalent bonds tend to all be nonmetals with nonmetals, and that is why you specify your prefixes. So N2O, those are both nonmetals. Nitrogen and oxygen are both nonmetals. So you have to think to yourself, okay, two nonmetals, I have to use a prefix. Nitrogen, di for 2 nitrogen, monoxide. CH4, well, that's 1 carbon. You can specify the mono part if you want, but usually if the first element is single, you can just call it what it is. The prefix for 4 is tetra. So we have carbon tetrahydride. Now, here, these were your nonmetals here. Now we'll do some ionic bonds. So we'll call this covalent ionic. I have aluminum and nitrogen. So you look at your periodic table. Why are there no numbers down here? Well, because aluminum is a +3 and nitrogen is a -3. So those two just cross-canceled each other there. And so what's nice about ionic bonds is you just basically write out the name and change the last one to an I. So it's aluminum nitride. Here I've got a sodium bonded to an oxygen. Sodium oxide. Nice and easy. Well, what if I wanted to know how to write out the formula? What if this is something that we're going to be asked on a test? Well, again, go to your periodic table and look at the charge on aluminum. Aluminum has a +3 charge. Oxygen has a -2 charge. So I'm going to take my +3 and my -2, and I'm going to do something that I like to call swap, drop, reduce. I'll swap and drop for you in one step. So there's the swap and the drop. When you swap and drop, your positive sign in front and your negative sign in front cross cancel. You can completely ignore those. Can't really reduce a 2 and a 3. So aluminum oxide, the formula is Al2O3. How about aluminum and sulfur? Well, make sure you go into your periodic table, look up what are my charges on aluminum. Aluminum's a +3. What is sulfur? Sulfur is a -2, just like oxygen. So that's nice. It's a very similar looking equation, aluminum sulfide. How about magnesium and oxygen bonded together? Well, magnesium has a charge of +2 and oxygen has a charge of -2. So I'm going to go ahead and swap and drop these, and I get Mg2O2. Now I can reduce that because a 2 and a 2 reduces to 1. So I can just write it as MgO, magnesium oxide. How about magnesium bonded to chlorine? Well, again, magnesium has a charge of +2 and chlorine has a charge of -1. So I'm going to swap those down. You don't have to write out the 1 if you don't want to. If you do want to, that's fine. But you're left with MgCl2, and that is your formula for magnesium chloride. So hopefully this helped you a little bit with how to make ionic bonds, how to name ionic bonds, and how to name covalent bonds.